Line. Intersecting lines. Find the point of intersection of the following two lines, or linear equations. Line 1, L1, is 2x minus 3y equals 1, and line 2 is 3x plus 2y equals 8. So we're going to find out where they both intersect. There are three possible approaches. We can do this visually from the graph, if we were given a graph. We can draw the lines and do it that way, and again visually. Or we could solve using algebra. So we'll start with the visually from the graph. So if we were given the two lines on a graph, and this was 2x minus 3y equals 1, and L2 was 3x plus 2y equals 8, we could look and see that roughly it's a 2, 1, 2 on the x and 1 on the y, where these two lines intersect. Pure visual inspection. So we would say the point of intersection is roughly here, 2, 1. We'll now do it by drawing the lines. Find any two different points for 2x minus 3y equals 1 and draw the line. So we can start with any point, but we'll just say we'll start with the value of x equals minus 4. When x equals minus 4, the equation is still 2x minus 3y is 1. 2 times minus 4, because we're using an x value of minus 4, 2 times minus 4 minus 3y is 1. Minus 8, but 2 by minus 4 is minus 8, minus 3y is 1. Taking the 8 to the other side, we get minus 3y is 1 plus 8, or 1 plus 8 is 9. Multiplying by minus, we get 3y is minus 9, or y equals minus 3. So at our chosen point, when x was minus 4, we found the y value would be minus 3. So the point minus 4 for x, minus 3 for y, is a point on this line, 2x minus 3y is 1. We need also to find a second point. So using x equals 8 as another starting point, 2x minus 3y is 1 is the line. So 2 times 8 in this case, minus 3y is 1. Or minus 3y is 1 minus the 16 for the 2 times 8. Or 1 minus 16 is minus 15. So minus 3y is minus 15, 3y is 15, y is 5. So at our chosen value of x equals 8, y is 5. So 8, 5 is another point on the line 2x minus 3y is 1. So we now have 2 points. And with 2 points, one at minus 4 minus 3, and the other at 8, 5, we can plot them on the xy plane and join them up with the line or the line segment L1 to represent the line 2x minus 3y equals 1. That's just the first line, that's L1. We'll go through the same process for L2. Once again, we find any two different point values for 3x plus 2y equals 8, and we draw the line. In this case, we take more traditional values, we say let x be 0. So it's still 3x plus 2y is 8, but 3 times 0 in this case, plus 2y is 8. 3 times 0 is 0, so when x is 0, we get 0 plus 2y is 8, or 2y is 8. If 2y is 8, y must be 4. So when x is 0, y must be 4. So the point 0, 4 is a point on this line. We now look for the second point, and we say, using x equals 4, 3x plus 2y is 8 is our equation. Using x equals 4, we'd get 3 times 4 plus 2y is 8. 12 plus 2y would be 8. Taking the 12 to the other side, we get 2y is 8 minus 12, or minus 4. And if 2y is minus 4, y would be minus 2. So again, if x is 4 and y is minus 2, the point 4 minus 2 is another point on the line 3x plus 2y is 8. And here we've got the points 0, 4 and 4 minus 2. 2 points we can draw the line, well, the line segment between them, representing 3x plus 2y equals 8. But we were interested in the point of intersection, so really we should use the same axes for both lines. So here we superimpose the first one, 2x minus 3y equals 1, on the second one. And we can see that, judging by our graph, it looks like they intersect at around 2, 1. And once again, we could do this visually. The point of intersection is approximately 2, 1. The only way to do it absolutely correctly, precisely, is to use an algebraic solution. Here we've got the two lines, 3x plus 2y is 8, and 2x minus 3y is 1. And this is from your algebra section. So in respect of equation 1 and 2, we could, for example, from 1, multiply everything by 2. So instead of 3x plus 2y is 8, we get 6x plus 4y is 16. And in the second case, instead of leaving it as 2x minus 3y is 1, if we multiply both sides by 3, we get 6x minus 9y is 3. The reason for doing this is to make the x coefficients the same. If we now subtract one line from the other, the 6x from the 6x, we get nothing. The 9 from the 4y, we get, subtracting minus 9, we get 9. So 9 and 4 is 13, and 3 from 16 gives us 13. 13y is 13. We find that when y is 1, these equations are intersecting. But what's the x value? Well, now solving for x, one of the equations was 3x plus 2y is 8. And if we use the value we received of y equals 1, we get 3x plus 2 times the 1 is 8. 3x plus 2 is 8, or 3x is 8, taking the 2 across, 8 minus 2. 8 minus 2 is 6. So if 3x is 6, x must be 2. So really what we're saying is that the point 2, 1 is the point of intersection. Let's check that with both equations. The first equation was 3x plus 2y is 8. So 3 times 2, the x value, plus 2 times 1, the y value. 3 times 2 is 6, plus 2 times 1 is 2. 6 plus 2 is 8. That's correct. Using the second equation, we had 2x minus 3y was 1. But 2x in this case will be 2 times 2, or 4. Minus 3, 1. 3 times x will be 3 times 1. 3y, so it's 2x, which is 2, 2, 3y, which is 3 times 1, so 4 minus 3 is 1, and that's also true. So confirmation that the point 2, 1 is the actual point of intersection, as we saw in all of the visual and the drawing processes as well. But we know from algebra it's precisely 2, 1.